the second half of the IPython tutorial covering rich display and the interactive widgets. During the second half here, we're going to be covering the interactive widget portion. And while people come in and get seated, I wanted to show you one thing with NB Viewer. If you go to NB Viewer and click on this image here, this will take you to the IPython documentation that is notebook-based. And we also have Sphinx-based documentation. This is the notebook portion of our documentation. And if you click here on interactive widgets, there are a number of tutorials. The content that we're writing for this tutorial, a lot of it will eventually appear in this context. And there are also some other examples here of using Interact that we won't have time to go into at this point. And I've got a local checkout of that repository here. And I want to show you this example to sort of motivate what we'll be talking about now. So we've seen how it's possible to teach Python objects about rich representations, HTML, PNG, JavaScript, etc. Widgets allow a bidirectional communication between a user interface running in the browser in the notebook and the Python kernel on the back end. And we've used this infrastructure to make it really simple to build user interface controls tied to computations in the back end, and which leverage the display system that we've been talking about for the first half of this tutorial. So as a simple example here, oops, actually this is the wrong image processing. That's the one I want. So as a simple example, here is an image object. So I'm loading the coffee data set from scikit image. And here's the coffee image. And again, notice the image object here has a representation that the notebook knows about. Here's a Python function that does some simple image processing. It takes the image as the first argument. Sigma is a parameter for a Gaussian filter. And then RGB are floats between 0 and 1 that adjust the RGB levels of the image. And then we simply call display on that edited image and return it. So here's that. And what's possible with the new IPython architecture is to quickly build a user interface that allows you to explore that function interactively. So the function we're going to use in this context is interactive. This is part of the new widget API. The first argument to interactive is the function we want to explore. So that's this edit image function. And then the remaining arguments here specify how the user interface for this function should be built. Fixed means that there should be no user interface for this particular argument, that it should just be a fixed value. And so in this case, this is the actual image that we're going to be passing in. For sigma, we want to create a slider that goes from 0 to 10 in increments of 0.1. For RG and B, we want to create sliders that go between 0 and 1 with increments of 0.1. And then we're going to display the object returned by interactive. So when we run this, let me compress my vertical space. What we get is that IPython automatically generates sliders for those parameters. And when I move those sliders, that function is called in the kernel, which causes the edited image to be displayed, right? And so here I'm adjusting the sigma. I can adjust the green and the blue levels, really bring up the red. And so we can edit and explore this image in real time. Yes? We'll get into that. Notice here I've passed floats in. If you passed integers there, you get an integer valued slider. And there's a lot more to that the next notebook will show. So how does this work? And I should note, this is a layered architecture, and the interactive function and its close relative, the interact function, are the highest layer and sort of the simplest way to get started. In a few minutes, John will come up and talk about the actual widget objects that lie beneath that top level layer that are a lot more flexible and powerful. And then he'll end by talking about how you can build your own custom widgets. All right, so we're done with that. Back here to using interact. So here are the import statements that you'll need. It's ipython.html.widgets. There's interact, interactive, and fixed. And then also import the widgets like that. And I want to show you at the most basic level how interact works. So let's define the simplest possible function that displays something, right? F of x, print x. Couldn't be simpler than that. And let's pass the interact function, or sorry, pass that function f to interact. And we're going to pass a keyword argument, x equals 10 here. And notice there's a semicolon at the end. I'll show you what the semicolon means in a second. When I run that, we get a slider. Notice the default value of the slider is set to 10. That's what we have here. It will go all the way up to 30, which is 3 times 10. And it will go all the way down to minus 10. When you pass a single integer, that is a shorthand notation that tells IPython to build a slider that will go from minus 1 of that number up to 3 times that number. Right? It's a shorthand abbreviation. And notice when you slide this around, the function is called, and we see the different values printed to the output here. If you pass a different variable to interact, or a different value for the same, so again, this is the same function x. In this case, we're passing x equals true. Can anyone guess what the user interface element for a Boolean would be? The checkbox, right? What this allows us to do is separate the function from the generation of the user interface elements, right? And when I click the checkbox, it goes true and false. If you pass a string, right, you get a text field. And the state, each time you change the state of the text field in the user interface, the function is called and the display is updated. Interact can also be used as a decorator. This allows you to define a function and interact with it in one shot. So here's a function, a g of x and y. We just print x and y again. For x, we want a checkbox. And actually, in this case, let's have the default state of the checkbox be false. For y, we're going to get a floating point slider that goes from 3.0 to minus 0.1. Here it is. Here's our user interface. 3.0 minus 0.1, it's false, and we can click on it, right? The arguments to interact, the first argument, when it's a decorator, is not present. When you use interact as a function, the first argument is the function that you want to explore. All subsequent arguments need to be passed as keyword arguments. Positional star args arguments do not work. It's also possible, as we've seen before, to fix arguments using fixed. And the typical situation here is that you have a function that takes some sort of large data structure, and that data structure is input to the operation of the function, but there's no real user interface that you would have associated with that. And for that, there's fixed. So here's h of p and q. And let's say I just want to fix q to be the number 20. I say q is fixed 20, p is 5. 5, we're going to get an integer value slider. And notice when we call the function, the second parameter, q, is always fixed at that value of 20. Yes? Is there a way to hide the interact code so all users see the slider? The question is there a way to hide the input here and all the user sees is this? Currently, there is not. We're thinking about ways of handling that, and there's a lot more on our roadmap that we can talk about. Yes?
Is there a way of controlling the range of sliders rather than just -1 to...
Absolutely. Yeah, we'll get to that in just a second. The question is there a way of controlling the exact range and increment of the slider? And there definitely is. So that gets us... I'm sorry, can you speak up a tad? If you can put pass, it won't print something. Yes? Yeah, absolutely. Yeah, your functions don't have to print something or display something. Yeah. So, widget abbreviations. The keyword arguments that are passed to interact, we call them widget abbreviations. It's a shorthand notation for building an actual widget object. These actual widget objects are going to be covered in a few minutes. Here's an example of using interact where instead of passing a widget abbreviation, we pass an actual widget object, right? And so when we pass x equals 10 to interact, remember I said it would go, the default slider would go from -10 to 3 times 10. That's equivalent to the following Python object, the following widget. And if we pass that widget and build it like this, we get the same result. Obviously, I can change, for example, I could change the default value here to 5. The default value is 5. And what this shows is how these widget abbreviations are working, right? There's a translation step from this shorthand notation to an actual widget object. But you should know that anytime you want to use an actual widget object with interact, you can. You can just pass it in. There's only one requirement, though, and that is the widget object that you use with interact need to have a .value attribute. Right? And so only some kinds of UI controls that have a .value attribute can be used in that context. Here's a little more information about the widget abbreviations that we support. So true or false corresponds to a checkbox widget. A string gives you a text area widget. If you provide a single, oops, sorry, I didn't want to double click on that, an integer scalar, a 2-tuple of integers or a 3-tuple of integers, you get an integer slider. And so if you wanted to specify the min and max value of the slider between -100 and 0, you could just provide those two numbers, those two integers as a 2-tuple. If you provide a 3-tuple, the third argument is interpreted as the increment. If you pass floating point numbers, as a scalar, 2-tuple or 3-tuple, you get a float slider widget. And if you pass a tuple of strings or a dictionary, you get a drop-down widget. And we'll show an example of that. So here is a 2-tuple of integers. So we're going to get an integer slider widget between 0 and 4. Between 0 and 4. If it's a 3-tuple of integers, the increment is 2. If you pass floating point numbers with that same notation, you get a floating point valued slider. And as John will talk about shortly, the value attribute of all these widgets is strongly typed. And so we actually are carefully tracking whether or not you have int or floats, and underneath the hood that it makes a difference. Here's a floating point slider where we've set a custom step size to 0.01. Yes? Yeah, let me actually run this cell without the semicolon. And what you see is that for interact to function both as a function and a decorator, it has to return a function, right? And when it returns that function, IPython displays the textual output of it, And usually you don't want that, right? And so the semicolon, you'll notice when I add the semicolon, rerun it, this line here disappears. And it does that. We made that choice to provide a single API that can be used both as a decorator and a standalone function. Yes? Not currently. Yeah. Another important point, and there's a lot to keep track of here. The keyword arguments that are passed to interact are used to specify how the widget is built, right? It's the widget abbreviation. The keyword argument passed to the function itself, the function you want to interact with, that is used as the default value of the function and of the associated user interface element. So here, there's a slider that's going to go from 0 to 20, increments of 0.5. The default value of the slider, rather being halfway in between the two endpoints, will be 5.5. Right? Does everyone see that? So if I change this to 7.5, the default value of the slider is 7.5. So it's important to keep track separately of the keyword arguments to interact, which specify the user interface, and the keyword arguments to the function itself, which specifies the default value of that user interface. So let's look at how the drop-down menus work. If you pass a tuple of strings, you get a drop-down menu. And notice here, we're just using our original function f that is going to print the argument to f. And each time I change this, the argument is apples or oranges, right? With this syntax for drop-down menu, the arguments that are passed to your function will always be strings. And those same strings will be the text that's displayed in the drop-down menu. However, sometimes you would like to use strings in your drop-down menu in your user interface, but you want a non-string type to be passed to your function. And for that, you can pass a dictionary. So here, 1 and 2 will be the string names in the drop-down menu in the user interface. The values that are passed to the function f will be 10 when 1 is selected, 20 when 2 is selected. So if we run this, notice 2 is selected, 20 is printed, 1 is selected, 10 is printed. Right? This allows you to separate between the keys which are displayed in the user interface and the values. One nice thing that this can be used for, we have an example in our examples repository that's shown on NBViewer, is that the values here can be anything in Python. So for example, you could have a user interface where the keys here are the names of an algorithm, and the values are Python functions which implement that algorithm. Right? And it allows you to build a user interface for switching between two algorithms that you implement. If you're running Python 3, these widget abbreviations can also be specified using function annotations. I don't have Python 3 running here. What that notation looks like is shown here. You give the variable name when you're defining the function, colon, and then the widget abbreviation. That allows you to then interact with that function without providing the keyword arguments to interact. Interact looks at the function, sees if it has function annotations, and then calls those in an appropriate way. IPython, if you really want to use function annotations and you're mostly using Python 3, but you still want things to work with Python 2, we have an ampersand annotate decorator in IPython that creates Python 3 compatible function annotations on Python 2. We don't expect that's going to be used too much. So you remember, our original image processing example used interactive rather than interact. And there's an important difference between these two. So here's a function f of a and b. The difference is that interactive returns an object, and it actually returns a widget object and does not automatically display that widget object. Anytime you call interact or use it as a decorator, you're going to immediately see the user interface that it generates. Interactive delays the display of that widget. Notice here I just ran that cell, and if I call type on that, I see that this is an instance of a container widget. That container widget has children. To display that widget on the page, I have to pass it to the display function. Right? And here I see the container widget with the two nested children inside of this. The benefit of using interactive is that these widget objects that are returned are reusable in different contexts. So you could use interactive to build a widget and then later on embed that widget inside of another widget hierarchy. It also has two attributes that allow you to access programmatically the current arguments to the function and the current return value. So notice here, you'll remember up above here, my current function adds its two arguments, right? So it's going to add the two arguments here, 4 and 14. That widget argument has keyword args that gives you the current state of the UI and a result, which gives you the current return value of the function, right? And so if you want to construct a widget, use the user interface to tune something, and then pull those values back into Python to do subsequent interactions or subsequent computations, interactive is the function that you want to use. In most cases, though, you want to start with interact. We have a notebook of exercises here for interact. There's some really fun things to do here. We are starting to run short on time, and I want to make sure to have enough time for John to go into detail on the actual widget objects. So have a look at this interact exercises notebook on your own, and I'll hand things off to John.
Thanks, Brian.
Yeah.
So widgets, what are these things? Really, they're things that live both in the backend, in your Python or Ruby or whatever kind of kernel you have, and in the front end, in the web browser. You can use widgets with interact, like Brian showed, to investigate different methods that you've made in the backend. But you can also use them more generically to build GUIs in the notebook, and just to send data back and forth between the backend and the front end. So Brian already covered the import, but you import the same thing. To create a widget, since it has a display wrapper, you can just construct the widget and return it. And that will show the widget. You can also explicitly display it using a display call. And if you explicitly display it and store a reference to it, you can display it again. If you display the same widget twice, you'll notice that the widgets are linked together. So dragging one drags the other. And this happens for as many widgets that you have displayed on the page. You can close widgets by calling the .close method. And that cleans up all the underlying message framework stuff. So why does displaying a widget twice work? Well, because widgets live both in the front end and the back end, when you display a widget, when you call that, the action of displaying a widget actually constructs an instance of that widget in the front end that's a reflection of the instance of the widget in the back end. So displaying the same widget twice, you're constructing two instances that reflect the same widget in the back end. Widgets have properties. The most common property is value. You can interact with these properties just like you can with any other properties of objects in Python. If you want to see all the properties that any given widget instance has, you can access the .keys property of the widget. And that will show what properties are actually being synced across from the back end to the front end. I'm going to hide these. So one tip is when you're constructing a widget, you can actually set these different properties without constructing the widget and then setting it later. You can just, in the constructor, set the properties. And that's what you saw Brian do earlier with interact, where he set the value, the min, and the max. It's a common desire to be able to display one type of data two different ways. So we have a special method in our utils class, in utils traitlets, called link, which allows you to link arbitrary traits of widgets. So you see here I display a float text widget, a float slider widget, and a float progress widget. And then I call link, and what link accepts is any number of arguments that are tuples, the first value being the instance handle, the second value being a string that refers to the trait that you want to link. So here I'm just linking value, value, value of A, B, and C. And if I drag the slider, you see the other widgets also update. To unlink, you just call unlink on the link object that was created. So I'm going to give you a brief overview of all the different widgets that are included with IPython. I'm going to exclude some, because there's a lot. But you can look at this list yourself just by calling dir on the widgets import. Anything suffixed with capital W widget is pretty much a widget, except for DOM widget and widget. Those are base classes. So there are 8 numeric widgets. 4 of them are float widgets. 4 of them are integer widgets. They have the same names. You just replace the word float with int, and you'll get the integer equivalent. Here I show some of the common properties, value, min, max, step. You can actually set the step, and description. What description does is it creates this little label to the left of the widget, and interact, when you're calling interact on the function and you're using those keyword arguments, it just takes the keyword argument and passes that to description. So you can change that if you construct the widget yourself. You can also display sliders vertically. There's an orientation keyword that you can pass. If you pass it the string vertical, it will display vertically, like so. Progress widget you saw on the other page. Bounded float text widget is a float text widget that actually is limited. So if I type 105 and return, it changes to 10, which is the maximum. Or negative 500, return 5, which is the minimum. But there's also an unbounded version, which doesn't have a min and a max. So you can set that to whatever you want. There are 2 different Boolean widgets. We have a toggle button widget, so, and a checkbox widget. For selection widgets, we have 4 different widgets. The one that you saw earlier was the combo box widget. And Brian had mentioned that you can either pass a list of items in as the values or a dictionary. Same thing applies to the widgets because that's the underlying framework. So here I pass in a list of numbers 1, 2, and 3, and they appear as is in the combo box. I can select one, query the value, it prints, but I can also do the dictionary syntax. So I can select 3, query that value, and it prints 3. There are radio button widgets. A select widget, which select is the HTML name for a list box. So we just want it to stay consistent with HTML, so we named it a select widget. And a toggle buttons group, which is just this kind of nice bootstrap, a group of toggle buttons. There are 4 different string widgets, 2 of which are editable, 2 of which only display strings. A text widget, which is a single line text box that doesn't accept new lines. Text area widget, which is used to type multiple lines. And then there's a LaTeX widget, which you can use to render LaTeX in the browser, and an HTML widget. Lastly, of the most common widgets, there's a button widget, which I'll explain on the next page. There are some exercises associated with that last page. If you go into the index of the tutorial material, you'll see at the end there's a widget exercises notebook. You can go over that, but I think in the interest of time, I will skip through those. So widgets have events. Some events are special, and then there's also a framework for generic events. The button has an on-click event, which you can see the doc string here. Here, I create a function that just prints button clicked, and then I call onClick to register the callback for that event. So when I display this button and click it, I see that that event is triggered. The text widget also has a special event on submit. It works the same way. So when I type and click return, it triggers the on submit event. And here I just print the text, whatever text is in the text box. I can print some more. But if you want it to clear, you have to do that yourself. So you would just do like text.value equals empty string. So the properties in the widget framework, the value, min, max, description, all those things, like Brian mentioned, are type safe. They're actually using a library that we have in IPython called traitlets. Traitlets has a complete set of helper functions, any kind of utility you could imagine under the hood. One of the things that you can do with traitlets is you can register callbacks for when the traitlet has changed. So this is the generic way of listening to different properties of your widgets in the back end. This is the doc string for the actual onTrait change call, which is the call to register the event listener. It's kind of a long doc string. But what you really need to know is that the callback can have 4 different forms. It can either be just a callback that gets called when the trait is changed. It can be a callback that accepts 1 argument, and if that's the case, it's going to be the trait name, 2 arguments, trait name, the new value of the trait, and then 3 arguments is the trait name, old value, and new value. So here I display an int range widget, and I call onTraitChange, pass the handle to my onTraitChange method, which just prints the value. And I also pass this additional argument. And what this does is says, hey, I just want to listen to the value trait. If I don't pass this, it will listen to all the traits on that widget, which is fine because value happens to be the only trait that's actually changing with this widget. But still, it's a good practice to be explicit and say exactly what you want to listen to. So you see as I drag that, it prints a flood of messages. So widget styling. I think earlier that gentleman asked if you could specify a minimum and a maximum on your slider, and you actually can, but you have to do it yourself manually using alignment, and we'll go over that in this notebook. This is just some HTML that I'm pushing to the page later to help with the display. So since all widgets are objects that live in the document object model, the DOM for short, in your web browser, you use CSS to style them. We have a method called setCSS, which allows you to specify a CSS key and a CSS value to set. Here I display a text widget, and I set the background to lime. You see it has a lime background. But you can also use hexadecimal color codes, because this is just straight out of CSS. So if you're familiar with CSS, this is probably boring, but if you don't know CSS, it's probably new. So doing that displays blue. You can also change the font color. It's just color, though. It's not for color or font-color or anything like that. And to reset a CSS trait, you just pass in an empty string, and that clears the styling. But my text is still white. So. You can also pass in dictionaries to set CSS. So if you need to set multiple attributes at once, you can just use a Python dictionary where the keys turn into CSS keys and the values turn into CSS values. Here's a button widget where I set the width and height to 100 pixels. So widgets have a notion of parent-child relationships. Here I've outlined the container widget that is containing the toChild, just so you can see where that widget is. To create a parent widget, you can pass in, you just construct your two widgets like normal, and then you pass in the list of the children as the children property of whatever you want your parent widget to be. A container widget is a very generic, just div element. So it's used for just displaying widgets in groups. And then you can move them around and style them as a group. Children can also be added to the child list after the parent has been displayed. So if you notice here, I don't actually ever display int widget. The only thing I do is pass it into containers children's list. And when I do that, it gets displayed. So there are a couple of kinds of special containers. These fancy containers allow you to do things like display groups of widgets, the first being an accordion widget. This is just like an example of how you would do like a from to Pathfinder or something. And you can see here I call set title on the accordion widget instance itself. And what that does is allows me to set those accordion tab titles. There's a tab widget, which is the same kind of thing, but tabs instead of an accordion. And then probably more useful, there's a pop-up widget, which isn't used for displaying multiple groups of widgets, but instead is useful for displaying these little pop-ups. And I think a gentleman asked earlier about popping out a plot. If you had a plot widget, you could use one of these pop-up widgets and set it as a child of set the plot as a child of the pop-up widget and then display it. And then you get this cool little pop-up that you can dock and undock from the output area. You can close and reopen. And you can move it around and you can drag it. And it snaps to the edges of the document. And the cool thing about this is it hangs out there and it doesn't move as I'm going through the rest of the browser. So here I increase the counter value by 1. I run a bunch of cells, and you see it's just hanging out there in the top corner so I can keep my eye on it. Increase the counter again, and it increases. And then I can close it, calling .close, just like any other widget. So widget alignment has a couple large pieces. The first being the labels. So those standard labels that are used by Interact, that description keyword. The descriptions themselves are right aligned, and the widgets are left aligned. If you have a label that's too big, it pushes the widget over to the right. And if you don't have a description specified at all, the label doesn't render. So then you don't even get the indent. Because widgets are in the DOM, we use DOM classes to group different types of styling and apply styling to multiple widgets at once. We provide an add class and remove class method on the widget instance. And this method optionally accepts a selector, which a selector is a thing that that allows you to specify which elements you want to add the classes to or which elements you want to remove the classes from. This is important because you need to know that if you use that selector, the calls to add and remove class are path dependent. You can make the same 3 calls in a different order and have a completely different outcome. So here I show that I create a bunch of div widgets, and I add a class to all the widgets with the red class. I remove the red class and then add a blue class to some of the widgets. Now, if I call that in a different order, the output is completely different. So because of this, you always have to call add and remove class after a widget is displayed. We have no way of caching these add and remove class calls prior to widget display, because if you display a widget like more than once, we would have to keep an infinite growing list of all the calls that were ever made because of this path-dependent nature of this call. So for aligning widgets, we use what's called the flexible box model. It's something that's been around for a while. They're just starting to kind of standardize it, but it's still a little bit broken. It's not perfect. The main things that you need to know is that widgets by default, when displayed in containers, use a VBox class, which means that the widgets are displayed vertically, one after another. But you can remove that class using the remove class and add class calls that we talked about above, and add an hbox class if you want your widgets to be displayed horizontally. Alignment with the flexible box model is kind of strange. There's something called packing, which specifies where the widgets or where the elements are with respect to the axis that they're rendered on. So if you add a start class, that sets the packing to start at the beginning of that axis. A center is in the center and end is at the end. And the reason why this isn't left, center, right is because if you have vertically displayed widgets, that doesn't make sense. It would be top, center, bottom. So instead, it's start, center, end. So it works for both cases. There are alignment classes, which are different than packing classes. They align on the axis perpendicular to the axis that the widgets are displayed. So align start, the widgets will appear at the top, in this case, and align center in the middle, and align end at the bottom. The last of the alignment classes are the flex classes, which allow you to create a grid. If you, by default, everything is flex 0. But if you specify flex on one of the elements, that basically says that that element is going to try to be greedy and take up as much space as it can. The higher the flex number, the more greedy the widget. If we only provide 0, 1, and 2, but I think in the regular flex model there are much more. So how does this apply to widgets? Here you can see I just create 3 button widgets. You can see that they're displayed vertically. But I can display them again, call remove class to remove that VBox class, and then call add class to add an hbox class to get them to display horizontally. Then I can set the width of the container to 100% and add that center class to get them to center align. So internally, IPython uses Bootstrap to do its styling. Bootstrap has a large list of styling classes. And you can add these classes to your widgets. To find out all the classes, you'll have to go to Bootstrap's website. But this is just an example of the different classes that you can apply to your buttons. Here are some classes that you can apply to containers. They create kind of like little alert messages. and then classes that you can apply to your progress bar widgets. The last thing in the styling notebook to talk about is visibility. All DOM widgets have a .visible trait. You can toggle this to hide or show the widget without actually destroying it. That just sets in the front end something that says display hidden. And a better example of why this would be useful is something like a forum where you want to hide a group of things. You can hide just the container that contains those widgets. So the last thing I want to talk about with widgets is building a custom widget. So the widget framework is built on top of something that we call the COM framework. The COM framework is a generic way of sending messages back and forth between the front end and the back end. The first thing to do when defining a widget is to construct the class in the back end. And to do so, you just need to create your widget class and inherit from this widget's DOM widget class. And that basically says, I want my widget to be displayed in the DOM. If you want, you can inherit from the standard widget class, but that's useful for cases where, for example, if you wanted to write a D3 widget, where you would write the renderer as a DOM widget, because the renderer would be displayed in the web browser, and then you would implement cameras and lights and other D3 objects as standard widgets and have your DOM widget display those. You would pass that in as children to the renderer widget. So the properties that we defined, I talked earlier about traitlets. Each property that you define on your widget, you have to pass a sync equals true keyword argument to that traitlet. And what that does is that tells the tells the widget framework to synchronize that trait with the front end. Here, this trait that I'm defining is a very special trait. It's _view_name. And what that does is it allows the front end to know what JavaScript object to create when you display your widget. So we haven't defined this hello view JavaScript object yet, but we will in a couple minutes. There are a bunch of other trait types that you can use when you're creating your widget. I've listed most of them here. There are a couple more, though. If you use a trait prefixed with the C, that's a casting trait. And so you can pass. It's not type safe. It tries to cast prior to setting that trait. So now let's deal with the front end. We use Backbone.js to implement the widget framework. The Backbone.js is kind of like an MVC framework. It separates the model from the view and the controller, but really the view and the controller in our case is one. So the first thing to do is to import the widget manager, which you can do using require.js. Require.js is what we use in IPython to handle imports in our front end. It's kind of like the Python import method. So here I call require and tell it that I want this widget class. And when it imports this, this actually returns a widget manager instance. And so that is the first argument here to this JavaScript function. If you wanted to import more things, you could add more things to this list. And you would have to add the same number of positional arguments to this function. So after importing our widget manager, we can define our view class. So here, I create a hello view variable, and I use this special extend method of the DOM widget view. That's actually a Backbone method. That's how Backbone does inheritance. There are many other ways to do inheritance and object-oriented programming in JavaScript, but since this is what Backbone uses, this is what we use in the notebook. After creating the class, it's very important to register the class with the widget manager that you import it. This allows, later when you display the widget, this allows the front end to know what view to create. And the last step is to define something for it to actually render. And we do this by overriding this render method. It's a special name. It's a special method. And by default, there's an element that comes with your widgets, which is it's a standard div element. This handle gets you a handle to the jQuery object that represents that div. And I can call .text to set some text inside that div. So if we run our code, hello widget, it actually displays a widget. So that's our first custom widget. So just a little bit about what's going on up here. You note I defined this view name, but I never actually defined the view name in the front end. In fact, I never actually define a model. The widget framework uses a generic model. So the model that you create in the back end here that we inherit from the DOM widget, the second that we display this widget, in the front end, it creates this generic model, this completely empty generic model. And then the backend sends an initial state push with all the different traitlets that are in the widget. And then that populates the model in the front end. And then a view is created using the special view keyword, and Backbone links that view to the model. So this that we did with the hello widget, it's not too cool because we can do that with the rich display framework that Brian showed you earlier. We can just push JavaScript or push HTML to the page. But what we really want to do is make something that's bidirectionally communicating. So to do that, I add another trait. I have to make sure the set sync equals true. I name it value because value is what we consistently use throughout IPython, and value is also what Interact expects. So if you want your widget to work with Interact, if you want your custom widget to work with Interact, you have to use value as the main trait name. So next, what I do is inside the view, that place where we had the string literal that said hello world, I replace it with a call to this.model.get, and I access the value attribute. And this will automatically be pushed by the backend to the front end, so that by the time that this view is created and displayed, this data would already exist in the model. This.model is a way to get a handle to the model that's associated with the current view. So that's great, but that won't update to anything that happens to the model. It will just display the value of the trait upon first push. But in order to get it to actually update when the backend is updated, we need to add an event listener to listen to the change of that value key in the model. And to do that, we use Backbone syntax. There's a method called .on. And .on accepts a string, which is the event name, a callback, which I have this.value changed, and then a context. By passing in this colon here, colon value, I'm telling Backbone that I'm only interested on the value trait, just the value trait of the model changing. The context here at the end is something specific to JavaScript. And what this does is this says that when it calls back this dot value changed, it will make sure to use the right context so the This variable, which is kind of similar to the self variable in Python, will be correct. Otherwise, it will have some weird not correct value. So if I run that, and then run the test, set the value, you can see that it updates to the new value. So now we want to try setting up bidirectional communication. We can't do that with this textual widget because it doesn't accept any input from the front end. So instead, what we'll do is we'll replace the textual widget with a spinner widget. A spinner is it's just a jQuery UI control. So here in this cell, what I do is I replace the name of the hello widget with spinner widget. I change the view name to spinner view, just to be complete. It doesn't matter. We could have still used the hello widget name if we wanted to. But I do change the value to a casting int that allows it to be an integer instead of a string. This block of code here that I've placed in the render function creates the spinner control and actually appends it to our element. But you don't really have to worry about this. This is all jQuery UI specific stuff. Whatever framework you decide to create a widget for will have a completely different set of commands to get it to display. But that's specific to whatever control you're trying to display. So I've removed the value changed event code because it's different for this object. So here, I register callbacks for the change and spin events of the spinner. The spin event is actually, it occurs while you're spinning the spinner, and the change event occurs when you finalize a state. And I call back handle spin, which sets a value on the model using this model.set function, which is like the model.get, but it allows you to set a value instead. And this step here is very important. I call this.touch, so that this is actually a method of the view, and this is generic to the view base. What this does is this tells IPython what view has triggered the change to the model. If you don't do this, if you have any type of output or any other Python code related to rendering output, it won't get routed to the correct cell because IPython won't know who sent the message, so it won't know where to display the output. So if you want your widgets to work with output, you need to call this.touch after every time you call this.set or after a group call of this.set calls. So here I can construct the spinner widget that we created. I can change the value. I can pull the value has changed. And I can also set the value from the backend. And lastly, I can test displaying this spinner widget with a slider widget using link, and I can verify that all the existing machinery still works with the spinner widget. Oh, looks like the link back to the index is bad. But yeah, that's it. There's a couple exercises inside the widget exercises notebook. I do think you should go over them because that was really, really fast for the amount of material that I covered. But we're just about out of time. But we have enough time for Q&A.
Yeah, so they wanted us to leave around 10 minutes for Q&A before we break for lunch. And so, yeah, questions.
So, unless I missed it, I'm wondering, is there a way to kind of tie the widgets together like a reactivity? So if you change value or data in one widget, it gets reflected in another widget. And the reason I'm asking this is I'm thinking this would be turned into a really cool IPython apps or app. And so you can have multiple widgets in a dashboard kind of setting. And so if you're changing one particular value in one widget, other widgets getting updated.
Yeah, definitely. I think that's what the link method does that I talked about briefly. It allows you to associate arbitrary traits. They don't have to be the same name. In the example that I show, I associate value with value and value. But you can do that with any other object. But if you want to do it with non-widgets, you can do that too. You just have to make sure that your non-widgets uses the traitlet framework. So you would have to expose whatever data properties that you wanted to link with these widgets using a traitlet, which we have a bunch of traitlets. Like we have an any traitlet. We have different ones. So you could find one that suited the job.
So can this thing, like, if you have like a database in the back end, like Postgres or Postgre, can this thing kind of interact with that as a data source?
Yeah, it can. But you would have to write custom code to expose that data source. The widget framework itself is, the majority of it is all stateful, made for sending and receiving stateful information. When you build your widget, you don't have to implement anything like delta compression or throttling. Like that's all handled with the widget framework. So all you have to do is expose the properties using traitlets, and it should sync back and forth. But if you find that there's something that's not stateful that you want to send, there's also a generic send and onMessage method, so you can just send and manually handle messages if you need to.
So I think the missing piece of the puzzle for a given database or data store would be to write a function that works like link, but that can link a widget trait to a value in your data store, right? Link works between two traitlets objects. You need something like link to bind data between a widget object that's using traits and some sort of object that represents your actual data store.
Or you could expose if you had access to the data store code, you could write it so that it used our traitlets, and then link would work with it.
Thank you.
Hey, I was wondering if you could talk a little about interact, and because sometimes we have, let's say, scripts that run some sort of simulation. You want to give the users the option of kind of changing the data, but you don't want to pre-calculate all the simulations because maybe it'll take too long. Does interact take that into account, and if so, how, and if not?
Not really, right?
So right now, each time you move the user interface controls to a particular configuration of state, we send that state back to the Python side. The function is called, and currently we do not cache those calls. So if you ever arrange the sliders in that exact same position again, it will actually recompute it. Caching in that sense is something we're thinking about. Another thing that we didn't really have time to talk about is that we are working on getting widgets to work on static web pages and also NB Viewer. And how that will work is that you will specify a set of user interface states that you want to pre-compute. We will save all that state and make that state available at a later time. For the usage case you're talking about where it's maybe really expensive and you don't want to pre-compute but you still want the interactivity, I think that type of pre-compute logic is something that will be important. But this stuff is brand new, and we're really trying to understand how people are going to use this, what are the problems that we have, and how to move forward with that.
Thanks. And just to clarify, so if you have interact widget range of 0 to 10, when you call it for the first time, it computes all the values from 0 to 10?
No. It computes them on the fly.
No. But one thing to add, you don't have to worry about. Hopefully you can't crash the kernel by playing with it, and queuing a huge list of things, because there is a throttle built in, so it should only send a maximum of 3 states from the front end to the back end if the back end is still processing. So it will see that it's processing, and then it will say, okay, I'm going to cache all my states in the front end, and it won't send any messages to the back end, so the back end won't keep recalculating as the user's going crazy in the front end.
Great, thank you.
Sorry, that answered my question.
Oh, that did.
These widgets are using a lot of compute-intensive resources, for example, in modeling, and I'm changing parameters there. How easy or tough it is to push that to Amazon or some other cloud in the back end?
So the important thing to keep in mind is that the back end, as we call it, is the standard IPython kernel, and you can run arbitrary code there. And so if there's a Python library for talking to a service, you can use it in a widget, right? So you could build a widget that uses Cloudera's new Impala Python API to talk to make Impala requests, and you could build that into a widget and have it do whatever you want. So and that's really, I think, part of the goal here is that traditionally you've got the web, right, where users are living and where a lot of visualization happens, but it's separated from where the data is and it's separated from where the code is. And by giving you the full power of Python on the back end side of the widgets, you can really do whatever you want.
So one of the things I liked was the slider. I'm thinking something along the lines of like a scaling for a sliding window. So that would effectively require 2. Is that something that just look at the code for how you develop the slider and kind of add additional parameters and then could create it?
Yeah, totally.
Simple questions.
Most of the effort there would be in developing the actual browser-based user interface, and then synchronizing, for example, the 2 values of the two slider components. That part would be really easy on the Python side.
Yeah, working in the JavaScript takes 5 or 6 times as long as working in the Python. So maybe even more than that, because in the Python, all you have to do is declare the traits.
Are you working on any projects that maybe interacting using like SQL Alchemy as an ORM in front of a database with IPython?
I'm not aware of any projects that are doing that yet, but again, it shouldn't be too difficult to synchronize an ORM with the widgets.
Thank you.
While people think about more questions, I did want to mention that we have 2 other IPython talks by Min, Paul, and Thomas, some of the other full-time core IPython developers. One on Saturday, one on Sunday. Min is going to be talking, I think your talk is on Saturday? Sunday. A more general talk about what we're currently working on, what's coming up in the future with IPython. And then on Saturday, Thomas and Paul will be talking more about the multi-language support that IPython has for building and running notebooks in other languages like R, Julia, Haskell, etc. So.
I have one question. If you have a JavaScript in a separate file, can you load the JavaScript separate file into the IPython?
Yeah. Using the display framework that he showed you.
Yeah, the question was, if you have a JavaScript as a separate file, can you load that into the notebook? Right now, you would open the file, read it in as a string, and send that as an argument to the JavaScript display object.
So one follow-up question. The same thing with CSS too?
Yeah, and there you'd do it through an HTML object and style tags. And actually, we didn't